Good day. I'd like to show you guys a little bit of maximization problem using linear inequalities. Here I have a problem set up that is basically let's say just a workshop that makes two products. They make chairs and they make tables. And we use two resources. We have wood as one of our resources and labor as our other resource. Now these resources are limited. Okay, what I mean by that is the available material. Let's say you only have 300 feet of wood available, 300 feet of board, and 110 hours of labor available. That's all you got. And let's say to make you're going to make a chair. Well, a chair is going to require 20 feet of wood and 10 hours of labor. If you're going to make a table, it's going to require 30 feet of wood and 5 hours of labor. Now, for each table that we make, we get $6 in profit once we sell it. And for every chair that we make, we get $8 in profit once we sell it. So our goal is to maximize the profit, given the constraints of the available material. Our first step is we want to define the variables and then write out the constraints. So we'll say let x equal number of tables and let y equal the number of chairs. Okay, and then to write out our constraints, we simply go along one line here. So we're going to say 30x plus 20y is less than or equal to 300. Okay, and 5x plus 10y is less than or equal to 110. And we just get these numbers just straight off the little chart that we have here. Okay, we're using these inequalities because that's the available material. I can't go over 300 feet of wood. That's all I have available in my shop. And during the work week, I only have 110 labor hours available to my employees. They can't work over 110 hours. So that's why we're using these inequalities. So once again, we're just getting our constraints just straight off the chart here. Okay, step 2, we want to define our objective function. Our objective function is the profit. We want to maximize the profit given our constraints. It's really easy. We're going to say max profit equals 6x plus 8y. That's our objective function. One more thing I need to add about the constraints before I forget is that the x and y values need to be positive. So to write that out, we're just going to say that x is greater than or equal to 0 and y is greater than or equal to 0. Okay, to graph our inequalities, we're going to need a couple test points. To graph a line, you basically need 2 points. So here's what we do. We're going to replace the inequality sign with an equality sign to just solve as you would any other graph. We make a t-chart. Okay, we're going to say when x is 0, what does y equal? So then we're going to say 30 times 0 plus 20 times y equals 300. Well, anything times 0 is 0. So cancel that. What we're left with is 20y equals 300. Y equals 300 over 20. So y equals 15. So when x is 0, y equals 15. Okay, next we're going to do the same thing by placing y to 0. So when y is 0, what does x equal? So 30 times x plus 20 times 0 equals 300. Anything times 0 is 0. You can cancel that. So we're saying 30x equals 300. X equals 300 divided by 30. X equals 10. So when y is at 0, x is equal to 10. Okay, let's do the same thing with the next equation. First, we're going to write it as just a regular equality just to make it easy on us. Okay, we make our t-chart. And when x is 0, what does y equal? So that's saying 5 times 0 plus 10 times y equals 110. So 5 times 0 is 0, so we're left with 10y equals 110. Y equals 110 divided by 10. Y equals 11. Okay, our next test point, what if y equals 0, what does x equal? So we're going to say 5 times x plus 10 times 0 equals 110. Okay, anything times 0 is 0, so we can cancel that. So we're left with 5x equals 110. X equals 110 over 5. X equals 22. Okay, now with these t-charts, we have our 2 points. So for our first equation, we have the points 0, 15, and 10, 0. So those are our 2 points to draw our line for this first equation. For the second equation, we have 2 points. We have 0, 11, and 22 and 0. So with these 4 points that we've just figured out, we're going to be able to draw some lines on a graph, and then we'll put the inequality sign back in to shade in one side of the graph or the other. Alright, so we have our test points to draw these lines on the graph for both of these equations. So let's start off with this first one here. So we're going to say when x is at 0, y is at 15. Okay, when x is at 0, here's x is 0, y is 15. So we can go ahead and I'll draw this one in green. So there's a test point there. And then we're also saying that when y is at 0, x is 10, so our other point is 10, 0. So that's going to be 10, 0 is right here. So that's our first line on the graph. Okay, and since we're using inequalities on these, see the inequality sign? That means we need to know which side of the line rings true. Okay, and to do that, we usually just pick a test point. Very easy one to do is pick the origin 0, 0, plug in 0, 0 into the equation, and then see if that rings true. Let me show you what that looks like. So we have 30 times 0 plus 20 times 0 is less than or equal to 300. So it's going to say 0 plus 0 is less than or equal to 300. Well, sure enough, 0 is less than or equal to 300. So we're going to say that this test point at the origin that we just plugged in makes the equation ring true. So that means everything on this side of the line will be colored in. Anything on the outside of the line up here does not make the inequality ring true. So that's called the feasible region. And that's going to be all this area on this side of the line. Okay. So let's go ahead and graph out the second equation. We'll draw a line for that and then figure out which side of the line rings true, the feasible region for the second line. Okay, so let's do this guy in red. We're going to say when x is, well, let's just say our 2 points, 0, 11 and 22, 0. So when x is 0, y is 11. So when x is at 0, y is 11 is here. And 22, 0, that's going to be this point here. Okay, go ahead and connect these two lines. Okay, that's what it looks like when this equation, oh my goodness. This equation and this one here. Okay, so here's the two lines. Now let's go ahead and find out which side of the equation rings true for the line in red. So we're going to say that when, of course, we use the test point 0, 0. So we'll say 5 times 0 plus 10 times 0 is less than or equal to 110. 0 plus 0 is less than or equal to 110. So is 0 less than or equal to 110? Yes, it is. So that means that everything on this side of the red line, because this test point rings true, everything on this side of the red line is a true statement. So normally what you do is you just color in this side of the line, leave everything out here blank. You just color this side of the line, just scribble it in, color it in. Okay, now since we're using two equations here, what it means is that our feasible region, which I'll draw in blue, is here, where they overlap. Okay, because here's everything green, right? Here's everything red. So we just kind of find out where those two lines intersect. And that's there in the blue. Okay, earlier I also pointed out that x has to be greater than or equal to 0. Y has to be greater than or equal to 0. And what that does is that kind of binds this feasible region to just the area in blue. See, if I colored in the blue over here, it wouldn't make these constraints ring true. So for y to be greater than or equal to 0, it has to be everything up here, right? Here's all positive y's. Here's all positive x's. So that's going to be the lower bounds of this feasible region, will be here. And we get that. We get these borders of the feasible region from these constraints. Okay, so here's our feasible region, everything in blue. That means that this feasible region means all the points that hold true for this equation, and this equation. We call these our constraints. Okay, everything in blue makes all these constraints and these constraints ring true. That's everything in blue here. Okay, and to finish up our problem, what we're going to do is we're going to take corner points. Take this corner point, this corner point, this corner point. We're going to plug it into the equation and we're going to see which one of these corner points gives us the greatest number. Okay, so that's going to be pretty simple. We're just going to plug in this, and this into the equation. So let's start off with the first one here. This is 0, 11. Okay, here's our corner point. Here's our corner point. What I mean by corner point is the corner point for the feasible region. Everything in blue here. So here's a corner point. It kind of looks like a baseball diamond in a way. Okay, so this would be approximately where third base is, right? So we're going to take this corner point from the feasible region. This corner point we know is 0, 11. Okay, we know that's 0, 11. So we're going to say 6 times 0 plus 8 times 11. What does that equal? So 0 plus 88. Well, that equals 88. So for our test point 0, 11, we're going to say that equals 88. Okay, let's do another test point. Let's do this one over here. This here is 10, 0. It's this test point here, 10, 0. Okay, so 6 times 10 plus 8 times 0. That's 60 plus 0. That equals 60. So 10, 0 equals 60. Okay, for our last test point, It's this one here. Now to find this point here, that's where these two lines intersect. So we're going to have to just do just a little bit more algebra. We're going to place these two equations equal to each other. We're going to write them in as equalities. So we're going to say 30x plus 20y equals 300, and 5x plus 10y equals 110. Okay, now to solve for a system of equations, what we can do is we could multiply negative 2 times R2. Okay, that's going to be the new row 2. Remember, we could change an equation by multiplying the entire thing through by any number. It doesn't change the equation. I can multiply this entire second equation by a negative 2. So first let me write this guy. We've got 30x plus 20y equals 300. Okay, when I do this, okay, negative 2 times 5 gives us negative 10x. Negative 2 plus 10 gives us negative 20y. Negative 2 times 110 gives us negative 220. Okay, now I'm simply going to add these two equations together to get rid of the y's. Okay, so 30x minus 10x, that gives us 20x. 20y minus 20y gives us 0y. And 300 minus 220 gives us 80. So we're left with 20x equals 80, x equals 4. Okay, now we have x equals 4. What we could do is take that and plug it in back into any one of these other equations and solve for y. So let's go ahead and plug it into this one here. We're going to say 5 times 4 plus 10y equals 110. Okay, 20 plus 10y equals 110. So 10y equals 110 minus 20. 10y equals 90. Y equals 90 over 10. Y equals 9. Okay, so our point here, our corner point here, we're going to say that is 4, 9. Okay, so let's plug in 4, 9 into our max, see what we get. So that's saying 6 times 4 plus 8 times 9. Okay, 24 plus 72 equals 96. So at the point 4, 9, we're going to say that's 96. So which one of these test points is the greatest number? Well, it's this guy here, 96. That's the greatest number. And this is the answer to, our final answer to this problem. That when we want to maximize profit at, what was it, $6 a table and $8 a chair. Okay, to maximize our final profit, we're going to make 4 tables and 9 chairs. There's our final answer. That'll give us the most profit given these constraints that we were given earlier. 4 tables and 9 chairs. Okay, thanks for watching. I hope you guys got something out of this. I know it's kind of a long process. It's kind of difficult maybe if this is your first time looking at it. Just go through it once again. It's pretty easy after you kind of get the hang of it. A couple things to keep in mind. X and Y constraints have to be greater than 0 because think about it. If you're working in a shop, you can't make -1 tables. How do you create -1 table? How do you build -1 chair? -5 chairs? You can't. So those constraints, those have to be greater than 0. Okay, and our profit, our max profit, we got that from how much profit per table or per chair we make. Okay, our constraints. The reason why they're inequalities is because that's the available material. We only have 300 feet of wood in the shop. We can't create any more than those 300 feet. And we only have 110 hours of labor. That's why we have these constraints. And that's the whole reason why we only shade in one area of this graph, is because of these inequality restraints. The inequalities means you have to graph one side of it in. Okay, so I hope you guys enjoy this. Please like and comment, subscribe. Let me know how I'm doing. Thank you for your time.